Hey guys, thank you so much for joining this session. This is the Meetup.NET Learners House where we are publishing these events. And this is the first event of 9 series events. We'll see that what it is in a minute. So this is the first event, it's there here. And this is my GitHub repo, Vishipailor. That's my GitHub repo. And very specifically, the work which I'm doing on Gen AI, AWS Bedrock in practice, it will be here in this. All the links has been given in the YouTube video. Okay. So with that being said, let's go and start discussing. So the first thing to look at it is we'll see what is that we are going to do, and then we will get deep into the session. So this is Gen AI with AWS Bedrock in practice. That's the title or the repo name I have given. And you can see that this is a 9-part series which I'm planning. And this is not an official training material. This is my personal learning journey. And you can go deep into this to find out. And here is what I'm planning. Like if you see the sessions roadmap, I mean, it could be, the cadence could be bi-weekly. That's what I'm planning. If people are having number of views very frequently, then I will increase the cadence. But as of now, I'm planning that the cadence will be bi-weekly. So if you see what is this 9 series which we'll be doing is, one thing is Bedrock mental model and Gen AI foundations. That's what we are doing here. And Bedrock platform deep dive and model exploration, Bedrock API and SDK, designing minimal Gen AI backend on AWS. And you can see that what all the services which we'll be doing. This is just a high level plan. I mean, whatever we have for the session 1, but this session 2 to session 9 is high level. I'm not restricting myself to 9 sessions. If things goes well, we will increase it to more sessions. But as of now, this is the plan. And with that being said, this is the one you'll go. If you go into this, you'll see a lot of these things, plan and other things. Let's go to the master plan of this one. I'll quickly come in here and let's see the master plan for a minute, because this is the first time we are spending time. So there are some of the things which I have laid down. So you can see the master plan and the quick view, both are talking about the same thing. So I'll close that. And first thing, if you come and see here under the session source code, we'll start it. Most probably we might start from session 2. And repository structure, everything is there. Now let's look at this Bedrock mental model. So let's spend time on this today's session. So planning like a quick 30 minutes or somewhere around that, which fits in properly. So if someone starts learning, it will be like beginner to a decent level. I don't say that beginner to expert level, but at least beginner to a decent level will be traveling in this one series. So by the end of this session, you should be able to at least know these terms like, okay, Gen AI, what is this foundation models, base models, or language model, large language model. A lot of people, they'll be speaking about all these things. So we'll come to, now at least you understand, oh, okay, I know this term. What does, there's something known as a foundation model or a base model, okay? And place this Bedrock, at least understand, okay, what is Bedrock? Even if not exactly placing like, okay, within the AI/ML system, Bedrock fits in here, we'll try this one. And one more ground rule is we will introduce some of these terms at least from a 60,000 foot or 30,000 foot or 10,000 foot level, and then we'll revisit in the next sessions. And some of the terms or concepts which we deliberately ignore speaking about, just to ensure that we are not derailing any particular session. The content is very planned and placed in a way that it fits in that particular session. So some of the concepts and other things will be deliberately will be ignoring that one. So why this matters? So some of these assumptions is I myself had made many of these mistakes. Okay, so I just wanted to speak about that one. Just give me a minute. I'm sorry for that. Okay. So some of these things I myself made some of this wrong assumptions. So I just keep it that way. So Amazon Bedrock and SageMaker, there are other couple of things which we will do deep dive, but we need to understand they both are they same or are they different. And LLMs are probabilistic; it's not deterministic. So that we need to understand. And system designer, while doing any project or any work on this. On these things, Gen AI. So we need to understand that we are being charged on tokens. What tokens are will come back, and we'll learn that one. Okay, without these right mental models, so then we might introduce unnecessary complexity, or uh, we might introduce unnecessary complexity, or we might get charged a high. So having the right mental model is very, very important. So let's see the core mental models. And by the way, I'm sorry to derail this one. I have created a playlist also here. So the playlist is it will be here in my channel .NET Learners House. You can see this Amazon Bedrock, and there's something Python fundamentals. We have three sessions, three videos there. This is the first video. I just wanted to give this piece of information. Okay, so let's come back to our session. So if you see that minimal hierarchy, there are a lot of terms. If you open LinkedIn, you will see industry experts like Vaibhav Agarwal and Brij Kishore Pandey, Shalini Goyal. A lot of these industry experts, they will be posting a lot of these things. And one of the thing which I remember from Mr. Vaibhav Agarwal was a pretty good graphic on the entire the system, like AML. I mean, where does all these things fit? Pretty beautiful image. You can follow them. You will learn more. I mean, I myself learn more from them. Okay, so where does this fit? If you see that at the top, you see that artificial intelligence, and then it is machine learning, then neural networks, then deep learning, and that's where the Gen AI comes. I mean, some people again they go deep and they will see what does Gen AI and where it gets placed between the deep learning and generative AI and the LLM and other things. For us, what is very important is okay, you should know that at the top there is something known as artificial intelligence. We'll go about the terms in a minute. And then something called machine learning, neural networks, deep learning, Gen AI. That's our focus. Then we have foundation models, which are, we'll see that. And the managed interface is Bedrock. We'll see that. So this is the mermaid diagram, and this is the ASCII for that one. Like if you see this, everything below generative AI, this one, generative AI, is abstracted away by the Bedrock. Okay, and one important thing is Bedrock we use to create systems or workflow. We don't use it for models and training pipelines. No, we create those generative AI solutions. Now you're speaking about model. What is a model? Okay, So if you see that the model, I mean the dictionary term kind of thing, a model is a mathematical function that has learned patterns from data and can use those patterns to produce outputs for new inputs. So that's the definition of model. So key thing is model as a learned mapping. Like you give this input and that input goes to the model and then it generates the output. So it learns from the patterns. Like if you see that example, if you give a text, it gives likely next word. Like if you say that sky is blue, I mean it is probabilistic, as we have discussed that uh, these things are probabilistic. It's not deterministic. Now it can say that sky is blue or sky is falling down or sky is cloudy, but it does gives the next likely word. Now, if you give a question, it gives an answer. Image prompt, it might generate image. It might not generate proper image. That does not mean that that particular model is wrong. It's the way it has been trained and the way we are giving the prompt. It could be that we might not give it enough information to give us the desired output. It's not always that uh, the model is wrong or the LLM or the kind of model which we are using is wrong. No, it's the prompt will play a key role in retrieving or in getting our output. So document summary to text to vector. We'll see some of these concepts in future sessions where I'll try to bring some Python notebooks where we can see this visually. Oh, what does this tokens means? How this tokenizer works and other things. Because the first session, I just want to keep it for the mental model where we'll create this. Oh, okay, this is what it is. This is what it is. Okay. So just to avoid this confusion, like it's not an API, it's not a chatbot, it's not a database, it's not a rules engine, it's not deterministic. It is probabilistic out, as we were discussing. It's a probabilistic out. So it's a learned behavior. So it learns based on some mathematical formula from the data, learn from the patterns of the data. So one important thing is we will at least discuss some of these vocabularies before moving further. Just give me a minute. So let's see this one. Model, we have seen that a trained function that maps inputs to outputs based on the patterns learned from the data. Like that means it has been trained on some data. You know, you give some input and it has got knowledge and it maps the input to an output, which you have seen few of the examples. And artificial intelligence, where it's a system which perceives, reason, and act intelligently. So, machine learning, it's a system that learns pattern from data instead of being explicitly programmed. So that's an inner layer. Now, if you see that neural networks, that's something which maps the inputs to output. It's a complex neural network similar to the human brain. Deep learning uses the large neural networks to learn rich representation from a massive data. And generative AI models that generate new content such as text, image, and code. There are different things like audio and video, different modalities are there. Just to understand different modalities, like text, we can call it as that is one modal. Text and image, like a multimodal, or image is a separate modal, and code. Now, foundational models, I'll park it discussing because there's a detailed session on section which where we will discuss the difference between these terms. What does the base model, foundational model, language model, large language models? Okay, so foundation model is large pre-trained model reused across many tasks without training from scratch. So someone has already trained it on a large data. So that can be used for many different tasks. So managed AWS service running these foundational models via API, as well as we have the interface also. So that's the reason before getting into deep into these things, we discussed something as a model. What model is. Now understanding the tokens. So tokens is very important, and that means when we are communicating with models, prompt engineering is very important. Like someone understand English, someone understand French, someone understand Hindi, someone understand Tamil, Telugu. Different languages are there across this globe. So when you're communicating in a language, the other person knows only language A, then you need to speak to him in a language A. When someone knows language B, you need to speak with him in a language B. Like a model understands this prompt engineering. I'm just creating an analogy. It's not exacting, just an analogy to discuss. So what is very important is when we speak to a model in a prompt, so it gives us a response. So if you want a different response, or you have to fine tune this one. Now I don't want to derail speaking about the prompt engineering. We'll keep it aside and we'll come back later. We'll do a deep dive on that one. So the cost estimation. So a lot of these things are priced at tokens. Like if you see uh, any of these providers, they charge based on the tokens. So the prompt design token limits affect what you send, and performance token count impacts the latency and throughput. So what is important for this particular session is we are being charged based on the tokens. So there are millions of tokens. Each provider will have different pricing. So let's see the tokenizer in AWS. I mean, this is not we are not discussing anything. It's just we are touching up. We are not even touching, just like a 60,000 foot. Okay. We'll come back and we'll see that how to go and how to create these services, how to check the models and other things. But just wanted to touch upon while discussing. Here is this playground where we can select this and apply. And here we can ask it to insert a sample one, and I'm calling it as calling and saying that hey, count this. And now if you see that I add a dot, and now it is 18 tokens. Now if I remove this dot, it was 17 tokens. Now when I added this, it is 18 tokens. Now I've added this. Let me add two more characters. Now I say that count is, now it is 29 tokens. It was 17 tokens and now it is 29 tokens. So what is this? Is it, we need to understand this one, why it is behaving that way. Now I added just an exclamation. Now it went from 17 to 18 tokens, and I added 8 to 10 characters. It jumped from 18 to 29 tokens. So let's try to fix our fundamentals. How tokenization works, we saw that. So the tokenization is not just a splitter, it breaks the text. It has got multiple algorithms that use it. So what is very important is tokenizer and model are a pair. Now, if you see, if we'll try. I don't know whether it supports or not. Let's try doing that. This is also giving the same one. Let me try getting something from Meta. Let's see whether it allows the tokens or counting tokens. Okay, it doesn't allow the counting tokens. Let's see something from Amazon that they allow. Okay, that's not allowed. So here we have anthropic models only. Let's try whether this is giving a different token. No, it's all same. Let's come back and let's discuss. So what is very important is this tokenizer, whatever the algorithm which they are using, and the model, they are a pair. So we can't say that the tokenizer, if Anthropic is saying that this is 17 tokens, some other provider might give something else. So it's not that that is better, this is better. It's like a tokenizer and a model, they are paired. You can't mix with other things. Okay, so it breaks the tokens into smaller pieces. It could be a word, it could be a character, it could be anything, and maps those tokens to numerical IDs, tightly couple how this model was trained. These two things, bulleted points, let's ignore as of today, but it breaks that. And it's not that it breaks exactly by words. It could be a single character, or empty space can be treated as a single token. Okay, tokens are not always by words. They can be subwords or part of words. In this, we already seen that. Why tokens differ across model? It uses its own tokenizer. As I told, different algorithms are there, like bytecode encoding, word piece, unigram. Different strategies are there for that one. So if you see that a same text in one model, it might be 4 tokens. To see this practically, let's see. Just want to ensure that we understand. Now we saw how this Claude it's doing. Now let's go to tokenizer from OpenAI. Now it will be a different count. Like if you see that this is like, it's not Anthropic model, it is GPT-4, and you can see this one. Here it says that 10 tokens. Now, as I was mentioning, here if you see that that one exclamation is being treated as 1 token, whereas here also we have seen that the once we added that exclamation, it bumped from 17 to 18. Now you can see here, if I remove that, now it is 9 tokens. If I add this exclamation, it is 1 token. And we'll see the other one where I added the random character. Now you see this guy, all the way it went to 20. Now you can see this, there was a space, and S is considered as 1 token, DL is 1 token, just alphabet K has been given a single token. So that's what we now we understand exactly. Now it doesn't break by word. It could be word or space and a word or a character. It could be different things. But what we need to understand is a model and a tokenizer. And there are different algorithms. We'll come back in future to understand those. Or we might not, because this is very specific to generative AI, but we'll see that if at all it makes sense to bring it, that concept to show uh, the concept, I'll get it. I mean, I was learning from different video courses, different books. So the code is already available by those authors. All I need to do is lift and shift and customize and present it here. So it's not a heavy lifting. Authors has already done. So I just want to speak about it. But we'll see without derailing our session. Now, tokens, I think we have spoken enough on tokens, and we'll come back on tokens. This everything is there in the GitHub repo. You guys can go and look at it. So let's learn some of the terminology. Like we hear this base model, foundation model, language model, large language model, different. Sometimes I myself uh, use this interchangeably. So I thought of, oh, okay, before I speak, I need to fix my fundamentals. So that's where I am coming from. Base model is like what training state is the model in. Foundation model is how broadly can a model be reused. And Language model, what type of data does the model work with? And large language model is how large and capable the language model. Okay, so that means what is this? Let's see this base model. So here, the base model is a raw pre-trained model before task-specific tuning and alignment. It was trained on raw data. Now, foundational model is large, reusable model designed to support many downstream tasks. It's like different tasks can be performed on this one. Here, if you see the base model is very specific, task specific. This is many tasks. And language model is understand and generates human-like model. It's like a text modality. It works with a single modality. And large language model is a large scale language model with a strong generalization and reasoning capabilities. It's on scale and the capability. So if you see this, how these terms relate with each other, describes where the model is in its training state life cycle, and foundational model is sorry, describes how broadly the model can be applied. Language model, what kind of data the model works with, and describes the size and capability of this one. Okay, so if you see this, Amazon Bedrock uses foundational models. Okay, it should be foundational, but I think foundation should also be good enough. So text models, image models, embedding models, and multi-models. Now you can see this. Each of these is a separate category. This is a separate category. It could be like a text, image, voice. So that kind of thing, like the same single model working with different kinds of inputs. Again, we'll come and do a little dive in this one. So why this matters for Amazon Bedrock? So the terminology clarity prevents us common mistakes, like treating all models as a chart-based LLMs, over-engineering, and choosing a right model without going on someone told or uh, we heard someone used it, let's start using it, or we read some documentation, oh come on, let's use this one as like a single uh, pill for all problems. Now we have to be very specific. We need to know the capabilities of a model before choosing it. So that's very important. Now generative AI. So what is this generative AI? So something which produces the content. I mean, this content, new content, it's not coming from a magic wand, but it was trained on a large corpus of data, and it learned, and using that knowledge, it produces the new content. Okay, and the key thing is that the model is probabilistic. It's not deterministic. You give a same prompt, you will get different outputs in different executions, or it might give same output. Again, there are different things will come into the picture, like temperature or top p and the kind of prompt, giving the constraints, and a lot other things are there. Now again, the context dependent output quality depends upon the prompt and the context. If you don't give, I'll stop it here because I don't want to derail this session. Let's fix the mental model and parameter driven. I was talking about the temperature and top P. Now, prompt engineering, just for awareness, it's like a 10,000-foot view. It's nothing more. It's an instruction, context boundary, behavioral constraint. So in Amazon, prompt directly influence the output quality, the token consumption, consistency, and variability, hallucination risk. We'll come back on the term hallucination in future sessions, but let's keep it as a secret for now. Okay, prompt engineering is not about clever wording, it's about designing an interface to a probabilistic system. So we'll not be covering this different kinds of prompts and prompt templates and other things. We'll come back at the later point of stage. So why this prompt engineering matters? So foundational models, we saw that those are probabilistic, and if your prompt is longer, it will cost. We'll stop till that because I just want to don't want to derail this one. Let's keep it like prompt is the way we are communicating. Like foundation models. Foundation model is a large pre-trained model that can be adapted for many tasks without retraining. Okay. So some people take the base model and train very specifically for a similar task. We'll come back on that one. So if you see the common task is text generation, summarization, question answering, image generation, embeddings. Okay. Foundation model trade generality for cost and control. Now, what is Amazon Bedrock? So it's a fully managed AWS service which provides API access to multiple foundation models. It is serverless interface and enterprise grade security and governance, model choice without vendor locking. Bedrock is about using models, not training. I mean, there are models which is there, we just use it. So we discussed about it. Let's come back and let's see what's on. I mean, we'll come back and we'll revisit. I just want to give you a pictorial representation. So I just came here. Now, if you see, there are other things which we will come back, like a provision throughput. And here we read that it is serverless. Now you're saying about provision throughput. Okay, let's wait till we'll come back to those that particular session where we can rightly place. And you can see this. This is serverless. There are 50. That means we can use any of these models. And if you see llama instruct, and I can click on this and click on open in playground. If it is non-serverless, then we have to purchase the provision throughput, and then we have to do. So this is very important. Or I can click on this and open in this model. So that's the instruct. Do you want to go with a single prompt or a multi-prompt? Like that we can see. And there are some other properties which are here. So we will not derail our session for the time being. So let me go back from where we have come. And now if you see that here, I don't know which one is, let's see this. Let me see this here. See this. It's not showing to use it. Maybe I'll use something very simpler one. Okay, text and code generation. Okay, this is allowing, so that it is showing like a serverless. We'll try to do something which is not serverless, or let's see this one. Okay, this is also serverless. So some of those things which, yeah, this one. I think for this it needs, oh, this is an embedding model. It's not a text model to try this in the playground. This is text and chart playground. So only the modality here it says is only those things will be able to use it. But what is very important is some of the models we need to provision the throughput, but we will come back at later point. But as we have discussed, these are the serverless one where we can use it. This is what we discussed about this one. Yeah, serverless interface, no infrastructure to manage. So Amazon is managing. So what Bedrock is not, it's not a chart product, it's not UI first AI tool. It's not replacement for SageMaker training workflows. It's not a framework and a deep learning tutorial platform. It's uh, a fully managed service which provides an access to foundation models. That's what is very important. This first point. I mean, not only API access, we have the console too. We'll see that once we come back. We are not, as I was mentioning, some of these things which we will deliberately not talk, just to keep focused sessions. And where Bedrock fits in inside this AWS, like you can have an high level access. Uh, so think of AWS AML services as layers, high level APIs like a recognition, comprehend, task specific, foundation models, access is Amazon Bedrock, custom ML workflows is the SageMaker. So here we are fitting it in where we need to fully manage the AI APIs. So it's filling in the gap between the first point, APIs, and the second point is ML engineering. That's where the Amazon Bedrock fits in. Okay. So just it's just an analogy. And if you see that, if you want to build a document summarization feature, so decision reasoning, foundation models handle summarization well. Bedrock provides the interface and no need for any customization or the infrastructure because we saw that it's an serverless. We can use this one. Okay. When we have the standard Gen AI tasks and natively security and governed and serverless pay-per-use model preferred. Um, and when not to use Bedrock, when you need to train custom models, you need to use SageMaker. Okay, hard real-time or fully deterministic requirements, traditional services. That's where we use those common failure modes, treating outputs are deterministic. We discussed this couple of times that the output what it generates is probabilistic. It's not deterministic. Okay, assuming that one model fits it all for all tasks. Now, there's a modality and how do you want to interact? One of the example is we might give input to a model in text and it generates output in a text, or it could be input in a text, output can be text, image, and voice. So that's like a multi-model on the output and a single modality in the input. Okay. Now let's see a simple demo. Uh, I mean, anything without demo is not complete until we do something. We'll not do too much of these things, but we will see one each. So single prompt, we can select anything which is pretty light. We don't need 1 million token. Something should do. Now I can ask what is TV, and I'll say that run. Now it is giving behind the scenes. If you see that input is 3 and output is 370, so that's the number of tokens here. There are a few other things which we will come back. The randomness, as I was mentioning, temperature and top P, the guardrails and other things are there. We'll come back little later, and we'll come back on the system prompt. I don't want to touch it at this point of time. And this is like a single prompt. Like we'll ask a query, model generates an output. It's like done and dusted. And again, you're not satisfied with the output. You need to fine tune this and again send it. So let's see one from the chart. And here let's select a different model. I think 8 billion. Let's see. And what is tokenizer? So So let's see this. Let's ask like, what is this tokenizer? So you can see this tokenizer is also known as Lexer or a scanner. It's a software component breaks the stream of text into sequence of tokens. Tokens are building blocks for the models. You can see this tokenization breaks the input and token classification, token normalization, and a lot of things we will know if we go deep, but we will stop here for understanding. I mean, we played with at a high level. I mean, without even knowing that what how to provision or AWS account and other things. Will come back a little later. Um so what this demonstrator is demonstration demonstrates is like model behavior, how foundation model responds to prompts, token processing, and probabilistic nature. And we can see this is a good point. Let me clear this off, and we'll ask what is Apple, and we ran this what is Apple in one model, and we'll ask the same question. See this here, as we discussed that the output is probabilistic, it's not deterministic. We ask the same question, what is Apple? It first time it gave this answer, next time it gave this answer. The question is the same, what is Apple? Okay, I used in capital letter. That might be a thing. What is an apple? See that the point which we discussed is based on our prompt, the output will change. So again, we'll give what is an apple in lowercase. See that will it give the exact? Uh, will it give this? A simple question. See that the same query we have given. What is an apple in lowercase? It gave this much big answer, and again this one. So with this we understand that the quality and the output from a model will be driven by one of the factor is prompt, and the second thing is the output what we get is purely probabilistic, it's not deterministic. So one thing is it makes our life easy, but at the same time we need to have a human in the loop. I think that should be good enough to understand that with the simple demo, we understand that it is probabilistic output and different models and tokens. At least at a high level, we saw that. And key takeaways we spoke about the generative AI is a probabilistic nature, and foundation models are powerful. And Amazon provides the managed access. It's not the training playground. Mental model is very important. Okay, I think with that we can conclude this session, and based on how the folks go through this video, I have planned another session in the next two. That's on 8th Thursday, 8th Jan. That's the second session, part two of second session in this 9 session series. So today, we'll see if we have a demand, we can increase the cadence, or at least we'll keep the bi-weekly. With that, thank you so much and have a good rest of the weekend. Bye.